This is the fast review for all the separation methods that we are going to meet. The separation method will depend on the mixture is made by what. If the mixture is between two types of solids, then I can separate them by selective solubility or by a magnet. If something is magnetic, like iron inside the mixture, then we can separate them by using a magnet. Like if you have a mixture of salt and sand, you cannot separate it, but if you have a mixture of iron and sand, then you can separate it. So if you have here, for example, iron and sand, the iron can be removed using a magnet. So selective solubility, it depends on the substance that you have. If you have salt and sugar, or sugar and sand, you can use the selective solubility. How you can do that for the selective solubility? For example, I have a mixture of AgCl and sodium carbonate. These two are two solids. One of them dissolves in water and the other one does not dissolve in water. So bring a flask and put water in it, then put the silver chloride and put the sodium carbonate. What will happen? The silver chloride will not dissolve, it will be precipitated at the bottom of the flask, and the sodium carbonate will be dissolved, so it will be soluble inside the water. After that, you can make filtration. You filter the sodium carbonate out and remove it from the mixture. So you will put your mixture inside the filter. This is the filter paper and this is the funnel. Then you will put it there. There will be a substance which is dissolved and this will go down inside the solution. We call this one the filtrate. It will contain water plus sodium carbonate. Why? Because sodium carbonate dissolves in water. And some other residue will stay here on the filter paper, will not be dissolved in water. This is the silver chloride. This is how you separated the silver chloride from the sodium carbonate. Again, you have a mixture of sugar and salt. So how can you separate the sugar and salt? It depends also on the selective solubility. So bring some alcohol here and put it in this flask. Then put your mixture, the sugar and salt inside. One of them will be dissolved, the sugar, because it dissolves in alcohol, while the salt will not be dissolved. So I will see here at the bottom, the salt will be not dissolved, so it will stay here at the bottom of the flask, while the sugar will be dissolved. So I can make the filtration again. When I make the filtration, the filtrate is soluble in water will come down. That's the sugar. And the salt, because it does not dissolve, it will stay here on the filter paper. It's called the residue. The salt, because it does not dissolve in the alcohol. Now, if you have a mixture of solid and liquid, how you separate them? The solid and liquid depends on if the sugar dissolves in the liquid, so the sugar dissolves in water. This makes a mixture which is soluble mixture. While if it's insoluble, for example, sand does not dissolve in water, so it is insoluble. The insoluble mixture is very easy to be separated by the filtration the same way we did a few minutes ago. Again, make the filtration process. This is sand insoluble in water. If it is insoluble, it will stay here in the residue on the filter paper. It does not dissolve inside the water, while the water comes down here, it will be called the filtrate. So sand in the residue and water in the filtrate. This is the filtration process. This is the filter funnel, and inside it the filter paper. What happens if the solid is soluble in water? For example, sugar is soluble in water, makes a mixture. This is a soluble mixture. How you are going to get the sugar back from the water after it has already dissolved? You will use something called crystallization. A crystallization is the way which you heat the water so that you get rid of all the water, so it goes out, and what remains is the sugar at the end. But if you do this directly, it will not be correct. It will not be called crystallization. In order to do that, you have to go through the following steps. You cannot just heat the flask or the beaker until all the water comes out because this might be okay with some substances and some substances it will not be okay. So what do you have to do the crystallization? In the crystallization process, the liquid is left to be heated until most of the liquid evaporates. After most of the liquid evaporates and it will be easier to form the crystals, then it will be put on a watch glass or an area or some glassware that can be easily evaporated the liquid from, and then it will be left until the crystals are formed. The crystals might be dried or left in an oven so that it will be remove the water from it completely. So let's summarize what we have taken until now. The solid, if there is a magnetic substance, it can be removed with a magnet like iron and sand. If not, then we can use the selective solubility. What about solid and liquid? If it's soluble, we can use the crystallization. If it is insoluble, we can use the filtration. What if they are liquid and liquid? The liquid-liquid mixture depends if the two liquids are miscible or immiscible. The liquids which are miscible means that they are fully mixed in all proportions. Like you put some alcohol and water, you can find them that they are miscible, they are fully mixed. Immiscible liquids, like you are putting oil and water, you don't find them, they are completely miscible. They will be separated into two layers. The method of separation of a liquid from a liquid which are miscible is the same distillation method we have mentioned here. So how do you do the distillation? You are trying to separate two liquids depending on their boiling points. So we have liquid 1 and liquid 2. The liquid 1 has a low boiling point and the liquid 2 has higher boiling point. So put them both in the boiling flask and start to heat it. If there is an alcohol, you cannot heat it directly. You cannot use the you cannot use the normal heater. You can only make heating using a electric heater or steam bath, but you cannot use the direct heater. Why? Because alcohol is a flammable liquid. It might catch flame and burn if it is heated directly with a normal flame. You cannot use the direct heat, you can use only steam bath or electric heat. We'll heat it in the steam bath. What we'll do, we have two liquids. The first liquid will boil and then change into vapors. The second one also will boil. The difference is that the boiling time will differ because one of them has a low boiling point. We can take this one first, cool it and separate it. So change it into a liquid. So again, this is liquid number one. It will start to evaporate. We change it into liquid and then separate it. The other one will not be boiled yet. So it stays inside the original flask. That's why I have separated liquid one from liquid two. What if the two liquids are miscible? The word miscible is like soluble. But in the height of liquids, liquid, we don't say soluble, we say miscible. Why if they are immiscible, they don't mix together, we use something called a separatory funnel. So here we use the distillation, here we use the separatory funnel. The separatory funnel or the separating funnel, you put the two miscible liquids together. So let's imagine that this is water and this is oil. You put them together inside the funnel, and this is different from the filtration funnel. It's a different funnel. It has a tab at the bottom. You just open the tab, and once you open the bottom, the tab, the oil will start to go down. So it depends on which one is heavier. If the oil is heavier, it will go down. If it's lighter, it will be up. So anyway, you open and then you let the first layer goes down. Once it goes down completely and the top layer is just remaining, you can close the tab, and that's how you separate them from each other. This one is used with miscible liquids or immiscible liquids. Use this one with the miscible and use this one with the immiscible. Now we can take also colors and pigments, and colors and pigments will be done by chromatography, for which we'll make a separate video. So let's just revise everything we did. Solid, magnet if magnetic, if not magnetic, use electric solubility. Solid and liquid if soluble, use crystallization. If insoluble, use filtration. Liquid, immiscible, use distillation. Miscible, use separatory funnel. Colors and dyes and pigments, use the chromatography. For some substances, the separation can depend on sublimation. You have two substances, two solid substances. One of them sublimes, and this other one does not sublime. Sublimes means it changes from the solid into gas directly. So your substance will be changed from the solid into gas directly. The other one will not. So the one that's separated from into gas will be removed, and the other one remains. But what are the substances that sublimes? This substance you should not know by yourself, you should only memorize. So three examples we have in our syllabus: the solid iodine, the dry ice. This is the solid iodine changes from the solid into gas. The dry ice or carbon dioxide in the solid form changes into gas. And the ammonium compounds, like any ammonium salt, ammonium chloride, ammonium bromide, this one changes from the solid into gas. This one changes from the solid into gas, and this one changes from solid into gas. So if you have a mixture of substances that contain any of these three, you can separate it using the sublimation. If you have substance that absorbs, you can use the absorption property to separate them. Absorption means sticking to the surface. I have two substances that can be used for the separation. If you buy some new shoes or some new devices or some new bag, you might find a small bag inside which have a different substance called silica gel. This silica gel benefit is to remove the moisture or absorb the water vapor or the moisture so that our new substance does not get spoiled. Also, charcoal. Charcoal can be used to remove smells and odors and gases and moisture from a substance. Here is, for example, something which is sold called naturally reactive charcoal that absorbs the smells from the fridge. You can put it in the fridge and then it will absorb all the gas smells because the smells are all in the form of gas. So if you have substance like silica gel or charcoal, you can use it to separate or some gases by their absorption. Just to revise, liquid miscible for distillation and immiscible by separating or separatory funnel. We'll explain also the fractional distillation. Fractional distillation is very much similar to the simple distillation. The only difference is that sometimes if you put two liquids, liquid 1 and the liquid 2, and try to separate them from each other, the first liquid and second liquid will have very similar boiling points together. So if you try to separate them, the first liquid will start to evaporate at the same time the second one tries to evaporate, so both of them will be removed at the same time. In this way, we can make a good separation between them. So if there is a small difference in boiling point, we have always to use something called fractional distillation. If it is big difference, we use the simple distillation. Here fractional distillation and here simple distillation. In the boiling points, like if you have, for example, 125, then this is big difference, but 178, like water and alcohol, you have to bring a fractionating column. The fractionating column is part of the apparatus that its benefit is to delay the evaporation of some of the liquids, like vapor one starts to evaporate, liquid one starts to evaporate and be removed, and the second one tries to evaporate, but because of the long distance and the glass speeds, which will prevent the second liquid from evaporating, it will be slowed down. So one can be evaporated and removed without number two intervening, so it can be separated separately. We'll make a separate video also again to explain the fractional distillation. It can be used in separation of miscible liquids, different, which has small difference in the boiling point. Fractional is 178, small difference, while big difference like 125, I can use the simple one. So miscible liquids with small difference, or can be used in gases. If I have mixture of gases, like I have hydrogen with oxygen with nitrogen, or liquid air, I can change the gas into liquid, then separate it, so everyone will be separated from each other.